Okay, so this one's a doozy. The main thing I want you to notice is we have this big fraction line here. So we're saying this whole top thing divided by the whole bottom thing. Now I have seen some teaching where they try to get you to look at the whole thing and find a common denominator. No, that's just too much. But what I like to do is I like to think of it as two different problems. So this is what the top version, and this is the bottom version. And I'll just approach just each of those two things separately. And then at the end, I'll take the top answer divided by the bottom answer. So I even like to kind of partition my paper off to call this the top, and then I give myself some room to do the work, and then I go, okay, this is the bottom, and then I give myself some room to do just that work, and then then I'm going to put here divide the answer. And I'll set aside a whole piece of paper. I may not need the whole thing, but I want you to understand that you need to give yourself room to do the work. And because you might need to go back and check it. The reason these are so frustrating, one of the reasons, is because there's so much room for mistakes. Tiny little mistakes just throw the whole thing off. So you want to be able to go back and check your work and see if you did things all right. So we're going to take the top part to begin with. Let me switch to my pen because that's not going to show up well. Okay, so we have 7 over 5a to the 4th minus 1 over 10a. That's just the top part. Now, anytime you have addition and subtraction with fractions, you need a common denominator. So we need to decide what is the common denominator here. The least common denominator, if it was just a 5 and a 10 sitting here, that's all, then I would say it's a 10. And so I'll write that part down. Excuse me. And then we need to have the same number of a's on the bottom. Well, this one has 4 of them, and this one only has 1. So we need them both to have 4. So 10a to the 4th is the common denominator. So now what we need to do is make them both have that common denominator. We need to change each of the fractions to adjust to that. So this one, the only thing it doesn't have is the 10. So we can multiply by 2 here and here, because whatever you do to the bottom, you have to do the top. This will cause this bottom part to become 10a to the 4th. So the top becomes 14, and the bottom is 10a to the 4th. Now we're going to subtract, and we're going to come over here and look at this part. This one has the 10 that we were looking for, but it doesn't have a to the 4th, so it needs 3 more a's. So we're going to multiply by a to the 3rd here and a to the 3rd here. And so that leaves us with 10a to the 4th, because there's 1 here and 3 here, total of 4. And then 1a to the 3rd. So we can just call that a to the 3rd. All right, so now that we have the common denominator, we can, because, with fractions, once you get the common denominator, you can then just add the tops or subtract the tops, whatever function you have. So now we're going to have 14 minus a to the 3rd. And so we're going to call that 14 minus a to the 3rd over 10a to the 4th. So this is my answer to the top. Now if we go to the bottom, we have 3 over 7a squared plus 7 over 21a. We need to figure out what the common denominator is. And if you just look at the number parts, the common denominator is 21. And then we need to have the same number of a's, so we'll call that a squared. And then we'll multiply to make sure they both have each of those things. So this needs to be multiplied by 3, and this needs to be multiplied by a. So we get 9 over 21a squared plus 7a over 21a squared. And now we can just deal with the tops. So we have 9 plus 7a over 21a squared. So that's the answer to the bottom. Now it's time to divide the top by the bottom. So my top answer was 14 minus a to the third over 10a to the fourth. And we want to divide by 9 plus 7a over 21a squared. Now, this is where we have to remember our rules for dividing fractions. And when we have division, we have to do two things. We have to change it to a multiplication, and we have to flip the second fraction. So we have 14 minus a to the third over 10a to the fourth. The first fraction doesn't change at all right now. And then 21a squared over 9 plus 7a. All right. Now, with multiplying fractions, you want to get rid of or reduce as much as possible before you do the multiplication. So, for example, here, I see that these two right here have, excuse me, sorry, it's an alarm going off, pardon me. Excuse me. Oops. These two have two a's in common, and I see that this has an a here, but the problem is that this part here has addition or subtraction going on. And when you have addition or subtraction going on, if you're going to eliminate something, you have to eliminate the whole addition or subtraction problem. So since there isn't a 9 plus 7a up here, I can't cancel that out. And the same thing here, there's not there's an a, you would think you could pull that out, but you can't. You can't, because it's part of a subtraction problem here. And so we'd have to get rid of this whole thing. But because this term down here, the 10a to the fourth and the 21a to the second, since they're not involved with any addition or subtraction, we can reduce some of those factors. So I can take two a's away from here, and that means I'm taking two a's away from here, and it leaves me with 2 left over. And really, that's it. I don't see anything else. 21 and 10 don't have anything in common with each other. As I mentioned before, you can't touch these minus and addition problems, subtraction and addition problems, because you can't take pieces of them away. Like, I know that 21 and 9 have a 3 in common, but the 9 is involved with addition, so you can't touch it, okay? So then we just multiply straight across the top and straight across the bottom. So we have 14 minus a to the third times 21, because that's what was left over here. And then on the bottom, we have, excuse me, 10a to the second times 9 plus 7a. That's it.